A cross B is magnitude of A cross B. It's the A multiplied by not B but its component along perpendicular components along A. That is A B sine theta. So this is the magnitude. Now if you take B cross A instead of A cross B, you have this component. If this is A cos theta, this will be A sin theta. So you are multiplying B with A sin theta. It means you are multiplying B with A sin theta. And this is the same, either whether you write as AB sin theta or BA sin theta. So it means the mod of the multiplication of A cross B is equal to the mod of the cross product of B to A, and both are equal to A B sin theta or B A sin theta, whatever. So this is about the magnitude. Now this vector product is a vector quantity. It must have a direction, and the direction is given by. So the direction is, and the direction direction of A cross B results in a vector, and direction of that vector, suppose that is a C, A cross B is C, and the direction of C will be perpendicular to both A and B at the same time. So if we suppose A cross B is a vector C whose magnitude is given by A B sin theta, but the direction of C is perpendicular to both A and B, and the direction of both of the C, which is perpendicular to both A and B, cannot be formed on this blackboard, but this will be maybe along the perpendicular to the A cross C must be here. So C is perpendicular to both A and B at the same time. So if you have two vectors, suppose we have two vectors A and B, and let us suppose this as A and this is B, and the C vector which is perpendicular on A and B may either be on this side or in this side. So which one is correct, whether this side is correct or this side is correct? So there is a convention which has to be followed. That the convention is direction, that is called direction convention, is that you put your right palm on the first vector. The first vector, you see, this is A, this is B. If this is the first one and this is the second one, you put your right palm on the first vector and rotate the fingers through smaller angles to align along the second vector. The thumb will point along the direction of the cross product. So if A cross B is C, C is on this side. And if you say, if you take B as the first vector, B as the first vector and A as the second vector, put your right palm here. You cannot rotate through smaller angles. So you have to put your palm like this and align along. So this C is along this side. So it means if A cross B, and if A cross B points along towards the observer, B cross A points away from the observer. So direction is given by, put your right palm on the first vector. Rotate fingers to smaller angle. To align along the second vector. The direction of the thumb will be the direction of the product. The direction of the thumb will be the direction of the thumb will be the direction of the product vector. Okay, so suppose this is vector A and this is vector B. So the cross product of A cross B. A is the first vector, my right palm is here, and the smaller angle is this much. This is the larger angle, but we have to rotate through smaller angles. So this is the smaller angle. Rotate the fingers to align along the second vector, which is B, and the thumb points away from the blackboard towards the observer. So if C, and in the copy on the blackboard, this is written as by a dot here. So it means A is rotating towards B and the C is coming out of the blackboard. So you are seeing the tip of the arrow. So this is the tip of the arrow point, because the arrow is, you are seeing from this side the tip. Now if you take B cross A, so B cross A means you have to put the right palm on the first vector, which is B, and the smaller angles is, so you have to rotate through smaller angles. You cannot rotate your fingers like this. You have to rotate like this. Put your right palm here, rotate the fingers to align along A, and the thumb points inside the blackboard. So it is, if it is C, then it is minus C. So it is A cross B. This is points outside the board. And if it is B cross A, means B is rotating towards this side, and so this is denoted in the book copy by cross here. Means this is B cross points inside the plane of the board, inside the board. Inside. It is crossed because you are seeing the arrow, tail of the arrow, and the tail of the arrow is like this. So it's seeing like this side, and the point is here, it's coming out of the board. So you are seeing the point. It's going inside. You are seeing the tail. So its tail is just like this. Yes, that direction is inside. And these vectors are also called axial vector. We will see studies some the vector which is along the axis. As for example, the cross product of two vectors results in a vector, and this type of vector is called axial vectors. So C is the vector C here, which is along the axis, are called axial vector. So these are all about the scalar and vector multiplication of vectors. So in next class we will solve some problems on this, and we will see the unit vectors and solve some problems in the multiplication of vectors. Okay.